Okay, guys, you're going to see this is our motion packet here. It's our packet that you're going to need this packet right here. And what we're going to do is I'm going to read the book to you. You can follow along if you choose. I'm going to stop at certain spots and you're going to fill in some answers here. But I want you to pay attention. This is what you're going to study when you go home, and because you won't be able to take the book home with you. So you're going to study your notes that you're taking here in order to help you prepare for the EOG. So as you are working here, please pay attention. So you need this packet here, and you're going to need, if you would like, I'm basically reading out of the North Carolina Coach Book. So this is good. It's going to help you be able to prepare for your test. Okay, so I'm just going to start here. If you would like to follow along, it'd be greatly appreciated. Which way do you travel from home to school? How far do you go to get to school? How fast can you go when you ride your bike to school? How much faster can a bus go? To answer these questions, you must describe the motion of an object including yourself. Position. Position is the location of an object. Hint, hint. You describe an object's position by saying where it is compared to another object. Think about riding in a car. Suppose you see a grocery store ahead of you. You ride to the store, then the store is behind you. The store is not moved. Of course, your position has changed compared to the position of the store. The grocery store, in an example, is a reference point. A reference point is any object that is not moving and can be described as the position of another object. A tree, a desk, a street sign, or a line on the road might be a reference of a distance from a reference point. Distance is the length of a line between 2 points. For example, your chair might be the distance of 8 centimeters behind your desk, the reference point. If you move the chair, its distance from the reference point changes. Motion. Motion is the change of an object's position. It is another word for movement. Hint, hint. When an object is in motion, its position changes. An object stays in motion as long as its position keeps changing. Think about riding a bike. The bicycle is in motion as long as it keeps moving along the bike path. The bicycle's position changes as you ride along. Suppose you stop at a mailbox. The bicycle is no longer in motion. Its position does not change when you have stopped. So if you look at your paper right here, position is the blank of an object. We've already answered. You describe an object's position by saying where it is compared with an object. A reference point is any object in any object that is and can be used to describe a position of another object. A tree, a desk, and a street sign on a road might be a point. Distance is the length of the 2 points. If I were you, I would be boxing certain keywords here. Motion is an object's position. In other words, for movement, when an object is in motion, it changes. An object stays as long as the position changes. You can measure the motion with a blank stick or a blank. And right here is where we're going to find that answer. You can measure motion. As with any other measurement, you must use the right tools and units of measurement. If an object moves in a straight path, you can use a meter stick to measure how far an object moves. A meter stick is a tool for measuring the length of a distance. A meter stick is exactly 1 meter long. You use this tool to measure the distance in centimeters or meters. Part of a meter stick is shown below. The number marks centimeters. You can also use a stopwatch, watch, or clock to measure the time during which an object is moving. A stopwatch is a good tool for measuring time in minutes or seconds. You can also measure time in hours. So if you'll notice here, you can measure motion with a blank stick or a blank. We just should have been able to answer both of them. You can also describe motion. You can describe it with words that tell direction. Direction is the path of a moving object follows. Right here. Direction is the blank of a moving object follows. You can use a compass to find direction when you describe it as north, south, east, or west. You can also describe directions with words such as right, left, toward, and away from. So right there, you can find direction. We're now on speed. Speed, you can also measure the motion of an object based on the distance of an object travels from a certain amount of time. Speed is a measure of how far an object moves in a certain amount of time. In other words, speed describes how fast or slowly an object moves. An object with a higher speed moves faster than an object with a lower speed. You might be able to ride your bicycle a distance of 8 kilometers in 1 hour, so that you would have a speed of 8 kilometers per hour. A car can go much faster. A car on the highway might have the speed of 100 kilometers per hour. To find the object's speed, you must know the distance or how far the object moves. You must also know the time or how long an object is moving. To calculate speed, you divide the distance by time. Suppose the ball rolls 10 meters in 5 seconds. You can find the ball's speed by dividing distance by time, as shown below. So right here, speed is a measure of how an object moves in a certain amount of. Describe how fast or an object moves. An object with higher speed moves within an object than lower speed. To find an object's speed, you must know the and blank. To calculate speed, you must know the time. If you remember from the notes we've taken before, we had a little triangle here. And remember what we talked about when we were talking about our distance and our time? Think about what letters go where. Let's look at the equation if you can't remember. For example, the unit of speed is meters per second. The ball moved 2 meters during every second it was rolling. Some other units for speed are kilometers per hour and miles per hour. Suppose 2 cars are in motion for the same amount of time. The speed of a car 1 is greater than the speed of car 2, so that car 1 will move farther than car 2. In other words, a faster object travels a greater distance than a slower object in the same amount of time. Now suppose the 2 cars are traveling at the same distance. If they start at the same time, car 1 will cover the distance shorter. The faster an object travels, the same distance in less time at a slower object. So think about it. Speed is distance over time. So when you're thinking about it, up here is your speed, or is your distance, and your time. So remember our thing, because distance over time equals speed. Now, if they give me speed and time, they might not give me my distance. So you have to remember that speed times time is going to give me my distance. So this is basically, think about this as an equation. This is a division symbol in a sense. Distance over time equals speed. So think about your equation and what you need to do. Now, you're probably wondering what these 1, 2, 3, 4, 5 questions are. And on this side of the question right here is a unit review on this lesson. And these are the answers that you're going to be filling in. Now, you're going to see another video in about a few more seconds where you're going to be able to type in the answers and make sure they're correct into your Edpuzzle. But at this current moment, these answers right here, down here, you're going to be using these questions here.